For this section, we're going to be creating the piston head from the assembly. We're going to be taking the measurements from this engineering drawing, and we're going to be using those exact measurements and transferring them over to our sketches on our main model. We're first going to start off by making this cavity. So we're going to start by seeing how far the center of this cavity is away from where it ends. Although it doesn't look like it, that measurement was to the center despite it not being directly on the line. This was because I took a measurement from the very center of the entire model rather than the center of the line. Before we get any further, make sure once again that your measurements are in millimeters rather than inches, as I've tested these. If you want to use inches, I'd recommend converting them over to get the best accuracy as possible. If you have trouble figuring out how to change your main units to millimeters, under the drop down bar menu under beside your name, you will see something called document units. Press it and change it to change your main unit to millimeters. The cavity that we're currently making serves a very important function, as without it, the connecting rod would just constantly collide with the piston head and we wouldn't get a smooth movement. Those dotted lines you see are what's called construction lines. They serve the purpose of being a reference line and not an actual stationary or not fixed, but rather extrudable line so that we can use these as a tool rather than an extruded face. I prefer to use construction lines. They are not required. If you just want to use a standard line, just remember to delete them afterwards. To get this angle, rather than creating a circle and trying to cut it, we're going to be using a tool called a fillet tool. This takes the corner of two lines and creates a curve with them. You can see here that once I select the fillet tool, I can then select the two lines and then ask me for how many millimeters I want this line to be. This measurement is of the radius of a circle if it were to be a full one. The only difference between this and a full circle is this doesn't require you to cut the rest of it. It just lines up the other two lines that you selected. Now we're going to be moving on to the main face of the piston head. This is where I would like to know that every measurement you see has been created in a real life model and has been tested to make sure that they work. So if you would like to make yours printable, I would recommend using each and every one of these measurements as accurately as you possibly can. Don't mind what happened here. This was an error on my part as I forgot to add decimal place for the 750 millimeters. So instead of being 0.75 millimeters, it ended up being 750. So all I had to do was delete my previous dimension and then add in the 0.75. As unnecessary as this step may seem at first, in a real-life engine, these little cavities perform a specific function. It allows for air and gas from fuel to travel through them to create less friction and generate more power. Although we won't be generating any power with this, I like to make these as I like the model to be as accurate as I possibly can. The reason I'm not taking measurements here is because these lines are all the same length, 0.6 going vertically and then 0.75 going horizontally. This I just did to save time. If you want to take your time and make sure every measurement is exactly how long, you can do that. And with this line almost done, this is the main face of the piston head completed. After this, we will be extruding it out using a revolve tool rather than the standard extrude tool, as this will give us a more cylinder face, which we desire, rather than just a flat edge. Once again, you'll see me using this, figuring out how far away from the center this measurement is. You can see it takes me a minute here. This is because I forgot I could just select the circle to get that measurement. However, I found a different place to find it. It is the same distance and it works. Since we zoom out, we can see that our sketch looks like half of what we need. This is all we need to create this sketch. We don't need any more, as when we extrude it out with the revolve tool, we'll get what we need. I made a small mistake right there. You may have noticed that I made that line a construction line. That was a mistake. That line becoming a construction line was the difference between the shape, that sketch becoming a full face, and that sketch becoming an open shape. An open shape cannot be extruded. Creating the circle right now, or creating it later, doesn't have a large effect. You'll see me create it and then likely delete it, as I can't use the revolve tool to make this separate. It will be a separate extrusion, and respectively, it will be completed separately, as it is a whole rather than a face. Now you'll see me create the standard line so that I can extrude it. Once again, I accidentally created a construction line, and you'll see that I'm not able to extrude this line. You can see my confusion as I'm unable to select the face. That's because no face has been made because of that construction line. After I add in that solid line from the top and bottom, I now have a solid face that I can extrude out. You see me delete the circle there. That's because I do not use it for the revolve tool, and deleting it now and creating it later, or just leaving it there, has no difference. But after we select the revolve tool and then select that construction line going through the center, we can see it creates that nice cylinder shape that we need. Going back out and going to the sketch, we are then going to mirror this cavity so that we can create that gap that we want. I do the mirror tool wrong here, or rather I should have used it For anyone wondering, the mirror tool when in a sketch works as the following. You first select the line that you want to use as your mirror axis. That means that any other line you select after select the mirror tool will be mirrored over that line in a parallel distance away. You can see here, since I only had one half of the face, I only got one half of the gap I wanted rather than the full thing. You can see here I attempted to use a mirror tool on the face to create it. However, when you're using the mirror tool on a full model, it doesn't work as well as it would in a sketch, and I was unable to effectively do it that way. Now you can see I use the mirror tool to try and get the lines that I want mirrored over. I select the lines that I want mirrored. This is important to note. If you have multiple lines selected before you select the mirror tool, it will assume that those are the lines you want mirrored. If you have one, it'll select that line as the mirror axis. It does not matter if you press the mirror tool first, if you don't press the mirror tool first. However, if you have no line selected and you press the mirror tool, the first line you press will become your mirror axis, and any line you select subsequently will be mirrored over. This is one of those tools that just becomes easier as you practice it. I don't have a simple trick for ensuring that every mirror works out. I would just recommend getting a simple shape or a simple sketch and trying to mirror it over a line in different ways, see which way you find most comfortable. And now that we have that main cavity, there's only two more steps we have left. Create the piston head as an open center and make it hollow, and then create this main hole. We're first going to start off with creating the main hole that allows the wrist pass to pass through it and connect it to the connecting rod and piston cover. And now we just select the face that we want to extrude. We use the extrude tool. Make sure you select the faces and not edges, as if you select the edges, it will create something and you won't be able to remove. Select symmetrical, and then extrude it all the way out. Now we have a gap for our wrist to pass through. And last but not least, we just gotta create this hollow as to use less filament when creating in real life. Sorry, I made a mistake there. We don't do that to use less filament. We make that hollow so that we can allow the connecting rod to sit in it and move freely within it. Over here, you see me take some time to get the correct measurement. This was from an error on my part. You can see that there is an R in front of the measurement that I want. R refers to radius when we're getting measurements. Aside from the circle with a line, that is diameter. So you'll see when I create this line and add in that measurement, it becomes a really small circle rather than the size that we want. This was because I unknowingly was using the radius dimension as the diameter. You'll see here that I couldn't figure that out in the moment, and I used a different measurement. I used the measurement of how far the gap between the two was rather than the radius or diameter. You'll see now that I then get the dimension of the 2 like before, and then I set it to 3 millimeters. Now we are ready to make our piston hollow. We once again select remove, and then we move it up to where we like it. 40 millimeters is too high, so around 30 to 35 millimeters is what works. And just like that, we have completed our piston head for our assembling, and you're ready to move on to the next part.